Hello, I'm Rick Meyer. I'm the Sencore Application Engineer responsible for training on the new VC93. The VC93 is an all-format VCR analyzing system which is a companion to the VA62A Universal Video Analyzer. We want to take you through all of the technical details of the VC93 today. We'll explain what it does and then show you how to use the various tests so you can see how they work. I'll start by listing the topics we will cover. Then I'll go back through each of these points in detail so that you get complete technical information. The VC93 is the only complete analyzer available. It's designed to work as part of your VA62 video system by adding special tests that isolate any playback or record problem in any VCR in half the time it now takes. It provides tests for all color under type VCR formats, which includes all consumer formats and both types of 3/4 inch U-matic. It's a dynamic VCR head signal substituter to isolate problems in the video circuits of any covered format. It also provides the head substitution for HiFi audio circuits. Its phase-locked chroma and luminance troubleshooting signals lets you apply effective signal substitution methods to any circuit from the video heads to the output. The VC93 has an exclusive servo analyzer which quickly identifies which servo is defective and whether the problem is in the speed or the phase loop. The VC93 has a built-in color test pattern so that it can work all by itself, or it can be connected to the VA62A for more complete video testing patterns. Connecting to the VA62A also adds tests of tuner and IF circuits to complement its analyzing features. Then, the VC93 adds special features to round out its full analyzing abilities. It has a special bias source to isolate servo loops. It produces standard audio and video signals to test recording circuits. Its digital meter monitors DC and peak-to-peak volts, both internal and external. And it's expandable if new VCR formats are introduced later. If you're like most VCR technicians, you probably do most of your work on standard VHS decks. But you probably also know that there are other formats in use and that your customer might bring any of them to you for service. The VC93 covers every consumer VCR format you may encounter. To choose the format, simply set the VCR format switch to the format of the VCR you are servicing. If you're not sure, the format is normally marked on the VCR itself. Super VHS is an enhancement of VHS that provides superior picture quality. VHS-C and Super VHS-C use a compact cassette for better portability in camcorders. Some customers still use Beta and Super Beta, so the VC93 provides those signals too. U-matic and U-matic SP are sometimes referred to as 3/4 inch formats. They are used in schools and hospitals as well as in broadcast studios and industrial settings. 8mm and High 8 are the popular new formats for the small camcorders. Even though each of these formats has major signal differences compared to the others, you don't need to worry about them when you use the VC93. Selecting the correct format with the VCR format switch converts every signal and every test to the correct type needed for the deck you are servicing. This makes every test work the same, no matter which VCR you want to test or repair. The first of these all-format tests is the dynamic VCR head substitute signal. This test eliminates guesswork associated with the video heads, rotary transformers, and head preamplifiers. Trying to test signals in the head circuits is tough with other methods. First, they are too tiny to measure with a meter or an oscilloscope. Second, they are a complex mixture of FM carriers and phase-rotated color signals, making waveform interpretation virtually impossible. The VC93 eliminates these problems with signal substitution. Maybe we should take a minute to talk about signal substitution so you can get a better feel of why it works so well. Whether you realize it or not, you use signal substitution all the time. Every time you hook up an antenna or a color bar generator to a TV receiver or VCR, you are injecting a signal you know is good to see if the circuits are working. That's all signal substitution is. Feeding in a good signal to confirm which circuits work. The difference with the VC93 is that you have the correct signal to inject anywhere inside the VCR, from the first stage to the output. In the playback circuits, the signal picked up by the video heads is the starting point. It serves the same function as the antenna signal used to operate the TV receiver. Just like the antenna signal, it's a low-level modulated RF carrier which is amplified and detected in the VCR playback circuits. The VC93 head substitutor then is just like your color bar generator. You feed a good signal into the head amplifiers and then watch a monitor connected to the VCR output to see how the circuits respond. Let me show you how to use this test. I'll be using a demonstration VCR so that I can easily switch problems in or out of the circuit. The symptoms, however, are just like those you will see in a defective unit. First, if you suspect there is a problem, you would normally open the VCR. And check inside for obvious mechanical defects like jammed tapes, bent tape guides, or foreign objects. If the transport looks good, you insert a work tape recorded with some video. Press the play button and watch as the tape transport loads the tape. If loading proceeds normally, check the monitor for normal playback. Here is what you often will see if there's a problem affecting the heads or the input circuits. There's a picture, but it has a high level of noise running through it. Sometimes you might even see more noise or nothing at all, depending on the defect. This symptom could be caused by a bad head, rotary transformer, record playback switch, head switcher, or head preamp. Let me show you how to use the VC93 to test the circuits related to the video heads. First, switch the VCR format switch to the correct position, in this case to VHS. Then set the playback range switch to the playback head sub position and the playback level control for maximum output. Set the playback signal switch to the lume position for testing lumens, or the lume and chrome position when working in color circuits. This has preset the VC93 playback output to duplicate the normal head signal. Connect the VC93 test lead to the front panel if they are not already connected. Then connect the black test clip to ground and either red test clip to one of the connectors coming from the rotary transformer. The connector is normally easy to find since it is between the head assembly and the circuit board. Now, look at the results in the monitor. You can see a hint of the signal coming from the tape mixed together with the color bar pattern from the VC93. By the way, this is a good time to remind you to use a tape recorded with a different signal than you will be using for testing. If your work tape has color bars, you'll want to supply a video pattern from the VA62A so that you can use a contrasting pattern. If you want to use the VC93 built-in color bar pattern, make sure that your work tape is recorded with a TV program or a different pattern. Notice that the two signals on the screen are not in sync with each other, since they are coming from two unrelated signal sources. If you're familiar with the Sencore VC93 VCR test accessory, you know that this is as far as you can go with it. Even though the VC63 is harder to use than the improved VC93 test, it has proven this method to be successful for thousands of users. The VC93 goes one better. You have a second red test clip to let you connect to both head preamplifiers simultaneously. Watch what happens as I feed the signal to the second preamplifier. The picture comes back to normal. If you see this normal response, you are certain that every circuit from the head connector to the output works. You are left with the heads, the rotary transformer, and the interconnecting circuits as the cause of the problem. The VC93 instructions tell you how to narrow the problem to the defective part. While we're talking about the problems associated with trying to test FM circuits, we should mention that you can also use the VC93 to inject signals into any test point up to the FM detector. You set the playback range switch and the playback level control to match the peak-to-peak amplitude of the signal at the test point, as shown on the schematic. Then, inject the signal and watch the monitor to see if the circuits after the injection point are working. By the way, you only need to use the black connector and one of the red connectors whenever you're feeding the signal after the head test points. It doesn't matter which red clip you use. Using signal substitution in the color circuits requires one other connection for reliable testing. Plug a test lead into the chroma lock input. Then, connect it to any of the SW30 test points in the VCR. The light next to the VC93 chroma lock input jack indicates if you have a valid signal. If the colors appear on the monitor, as you see here, the color circuits are working. If there is still no color, reverse the phase with the button below the light. If there are still no colors, troubleshoot the color circuits. This new VC93 feature eliminates the random color lock that you saw if you tried to do color testing with the VC63. This simplifies troubleshooting for those occasional color problems you encounter. VCRs with HiFi stereo use spinning heads for audio too. VHS decks have an extra pair of HiFi heads. These heads have all the same problems we discussed for video, namely signals too small to measure and too messy to interpret. In addition, the circuits might mute the audio, masking the true symptom. The VC93 takes care of these problems with its unique HiFi stereo head substituter. You use this just like the video head substituter. Just like video, you don't need to know the differences among formats, since the VCR format switch automatically takes care of the variations. To use the signal, just set the playback signal switch to one of the three audio positions: stereo audio, right only, or left only. Inject the signal at the head connector and listen for an output on the monitor speaker. The VC93 HiFi substitution signal also helps with muting because the substitute signals are supplied continuously. This bridges over switching errors, unmuting the circuits to help you find timing errors. Oh, there's one more similarity between audio and video signal substitution. The signals are available for substitution right at the rotary transformer output and at levels to inject at later stages too. You can feed the signal anywhere up to the input of the FM detectors to isolate defects quickly. We're finished with the head substitutor and FM signal injector. So let me stop the VCR, disconnect my test leads, and switch the problem out of the demonstrator circuits before we discuss the next VC93 feature. The VC93 drive signals take signal substitution to the rest of the VCR circuits. The drive signal switch selects a signal to feed into any circuit after the video, chroma, or audio detectors. The output is isolated from ground, so you don't have to worry about critical common points. The output also uses Sencore's exclusive swamping drive amplifiers, so you don't need to disconnect existing components when feeding in substitute signals. Just feed the signal right over the top of what's already there and watch for an improvement on the monitor. Here are the provided signals. Composite video substitutes for signals in the output circuits, such as the RF modulator input. The luminance signal replaces signals between the FM detector and the YC mixer. The chroma signal replaces signals after the recovered signal has been converted back to 358 MHz. The audio signal lets you work in HiFi circuits after the FM detector or in any of the linear audio stages. The 358 MHz signal replaces the master oscillator or the color reference. The head switch signal confirms the head switching circuits work correctly. This is one of the signals which automatically changes depending on the VCR format you selected. The signal is at 30 Hz for all formats except for VHS-C. Then it changes to 15 Hz to agree with the signal normally found in the VCR. The SW30 signal is always at 30 Hz and is timed to agree with the head substitution signals. Finally, the chroma key pulse lets you substitute for the phase rotation signals in the color circuits. We say that these signals are phase locked because they are properly timed compared to the substitute signals coming from the playback output section. They are also properly timed to agree with all of the signals supplied from the VA62A Universal Video Analyzer when you have it connected to the special synchronizing jack on the back panel. This gives you even more capability since you can substitute signals in any combination from the VA62A or the VC93 with the same dynamic results. The VC93 Servo Analyzer is totally new and unique. It lets you confirm whether the servos are working correctly even without removing the cover from the VCR. It finds marginal operation such as that caused by a poor pinch roller or worn belt. When you're troubleshooting, the Servo Analyzer also lets you make tests in the circuit to further isolate problems to the exact circuit. Before I show you how to use the Servo Analyzer, let's take a minute to understand each of the tests. The tests need a specially prepared videotape with an audio signal which was recorded in the proper phase reference compared to video. Sencore supplies these tapes for VHS, VHS-C, Beta, and U-matic. The Servo Analyzer test switch lets you select any of the 5 new servo tests. You should perform these tests in the sequence on the function switch, starting with the servo's lock test. The servo's lock test gives an overall check of both the capstan and the drum servos to confirm that they are working correctly. If this first test tells you there is a problem, the other 4 tests help narrow the defect to the correct area. The next 2 tests are of the capstan servos. The first checks for speed errors, and the second checks for jitter or short-term speed fluctuations. Then there are 2 similar tests for the drum servo, a speed error and a jitter test. There are 2 ways you can connect the VC93 to the VCR, depending on the symptoms. If the VCR is supplying both video and audio, you can make all the tests by connecting the performance test lead to the VCR's video and audio output connectors. Since these are on the back of the VCR, you don't need to remove the cover. If a defect has muted either output, the VC93 won't have the signals it needs to make the test. In this case, use the troubleshooting test lead, which lets you connect to the CTL signal and the SW30 signals inside the deck. I'll show you that in just a minute. So, starting with the performance leads, we make our connections. And place the servo test tape into the VCR. Notice that the display shows dashes if there is no signal applied. It will also show dashes if either the audio or the video signal is missing. By the way, if only one signal is missing, only those tests that need the missing signal will show dashes. The tests that use the other good signal will give normal results. If the signals are adequate, the display switches from dashes to a number. Press play and watch the digital display. After just a few seconds, a good or bad indicator comes up. The pause is needed for the signals to stabilize and for the VC93 to confirm whether the signals are timed correctly. The good-bad indicators let you make the test without interpretation, as the VC93 does all of the calculations for you. Before we go on, let me take a minute to explain how these tests work, so you will understand why it is reliable. Sencore has applied for a patent on the servo analyzer, so we don't have to worry about keeping it a secret from you. First, let's think about servo theory for a moment. Both the drum and the capstan servos should lock the motors and other mechanical parts to an internal 30 Hz reference signal. Most VCRs have this reference buried down inside an IC. So you can't actually compare each servo to the reference to confirm that they are locked. However, if both servos are working, there should be a fixed phase relationship between the linear audio, which depends on the proper tape motion, and the vertical sync pulses, which depend on proper control of the drum. The VC93 test tape is recorded using an audio signal which has been phase locked to the video. In fact, the audio is 8 times the vertical frequency, or 479.52 Hz. By the way, these signals must be recorded directly from phase lock signal sources, so it won't work very well to make a copy of the test tape with another VCR. If you need other tapes, Sencore will provide them through our customer service at a reasonable price. If the servos are defective, one or more of 3 conditions will occur. 1, the frequency of the audio will be wrong. 2, the frequency of the video signal will be in error. Or 3, the phase relationship between the video and audio will be incorrect. The VC93 readout is a combination of all 3 of these factors. By the way, these tests are so sensitive that they can detect servo errors that are not yet bad enough to cause symptoms in the video or the audio. This prevents callbacks, since you can correct a problem like a loose belt or a warped pinch roller before they get so bad to be a complaint. It's a good idea to make all 5 tests, even if the first test shows that the servos are locked to each other. Subtle problems, like a 358 MHz master oscillator that is running off frequency, may provide a locked picture but produce marginal compatibility when playing a tape recorded on another VCR. The other tests tell you whether the defect is in the capstan servos or in the drum servos. This is especially helpful when capstan problems are minor and affect the audio to such a small extent that you cannot hear the fluctuations when judging performance by listening. These subtle servo problems are especially common in the newer VCRs, which have speed loops which run so close to the correct rate that the VCR operates almost normally with a defective phase loop. In these VCRs, the video might drop out once every 20 or 30 seconds and appear normal the rest of the time. The VC93 identifies these problems and also confirms which servos are locked. What do you do if the video or the audio signal is muted or otherwise missing? Use the troubleshooting test lead and connect to the circuit board. First, let me explain the signals you need. You use the SW30 signal and the control track or CTL signal. The SW30 provides the VC93 with the same information as the composite video, and the CTL signal provides the same information as the audio when using the performance test leads. These test points are often marked right on the board, so you can find them without a schematic in many cases. Connect the black test clip to circuit ground, the red clip to CTL, and the yellow clip to SW30. Then run through the test just as you had before. The VC93 automatically detects which test leads you are using and converts the readings for you. You have exactly the same results whether connected to the external audio and video jacks or to the internal test points of the tape deck. By the way, be sure you use the correct test leads for the tests, so the VC93 knows what correction to apply to the signals. If you use the wrong leads, for example, you use the test clips to connect to the video output jack instead of to SW30, the results could be misleading. Each servo has a speed and a jitter test. The speed test confirms that the servos are locked. It's important to remember that an error here doesn't necessarily mean that the speed loop is the problem, only that the servo is running at the wrong speed. The troubleshooting chart tells how to determine whether the problem is in the speed or the phase loop. The jitter test generally finds mechanical problems. For example, a bad motor bearing, a hardened pinch roller, a loose capstan belt, or a bad holdback brake can cause excessive jitter. The beauty of the VC93 servo analyzer tests is that they can be done in less than 2 minutes. The troubleshooting guide directs you to the most likely circuit that has the defect. Then you can use your SC61 waveform analyzer, your Z-meter, and your other test equipment to narrow the defect down to the defective component. The next VC93 feature is pretty straightforward. The VC93 has a built-in source of NTSC split-field color bars. This lets it operate all by itself when you want general tests. But for even better troubleshooting capabilities, you can connect the VC93 to the accessory drive jack on the back of the VA62 Universal Video Analyzer. Now you have available any of the VA62A video test patterns as well. For example, the 10-bar staircase video pattern dynamically tests the FM demodulator to assure good brightness and contrast. The multi-burst bar sweep pattern dynamically tests the video circuits for full bandwidth. The chroma bar sweep pattern tests full color sideband capability. The internal pattern gives you the choice of using the VC93 by itself, while the external pattern ability gives dynamic testing. You have the choice. Using the VC93 with the VA62A also adds complete RF and IF troubleshooting signals. When connected to the VA62A, you can confirm the tuner works correctly, isolate defects associated with shifted cable channels, or check the automatic fine-tuning circuits right from the antenna input. When you suspect IF problems, signal substitution lets you move through the IF stages right up to the video detector. When working with stereo VCRs, the VA62A system also brings MTS stereo tests with the addition of the ST65 MTS stereo adder. You have your choice of how much troubleshooting capability you need for your business. The VC93 has a number of other features which round it out to a complete analyzer. First, it has a servo sub-bias supply which is designed to let you take manual control of the servo circuits. The VC93 supply is limited to 10 volts to make it easier to set than the 30-volt bias supply on the VA62A. This lets you break the servo feedback loops to pinpoint the exact cause of servo problems. Second, it has standard video and audio line outputs, which connect directly to the video and audio inputs of any VCR. This is especially important when you're troubleshooting record circuits. Third, it has an auto-ranged signal tracer, which tests peak-to-peak volts or DC volts. These tests let you quickly check for signal levels or lets you monitor a test point while substituting a signal in an earlier stage. Fourth, the VC93 monitors the signal level of any of the drive signals. This ensures proper levels and also tells you when you've connected to a shorted component, since the level will show signs of loading. The final feature of the VC93 is that it is obsolete proof. Spare positions are left open on the VCR format switch, which can be updated if additional color under formats are introduced in the future. Input and output accessory jacks provide for direct connection to the VA62A for further expansion if the need arises. It's a complete analyzing system for today and for the future.